do in taking a look at these quadratic functions is, first we need to know the form they're in. Now, basically, the only real thing, honestly, that I need to know from this form is where A, B, and C are. Because those are values we're going to be using to plug into different things. You're like, well, they're just in order anyway. Right, which makes it even easier. Because when we graph a quadratic, something with an x squared, we get this kind of U-shaped looking thing that typically is going to open up, or it can open down. We won't do anything with having them open sideways. That's a little bit different of a concept we don't really touch on here. Anybody know what the fancy name for the U-shaped figure is? It starts with a P. Parabola. Nicely done. Okay, so from here on out, I will not call it the U-shaped thingy, but a parabola. Okay? So, a few things we can learn about this parabola just by looking at the equation. It's going to open up if the A value is positive. In other words, if the number in front of x squared is positive, it's going to open up like a U. If that A value is negative, can open down, more like a hill or an N that somebody forgot to put their little line on. So we've got A is going to be positive or negative, and that's going to base us our up or down. Whether it gets wider or skinnier is also going to depend on A, but that's going to depend on the absolute value of A. Now, why are you talking about absolute value, Harty? I don't see absolute value on any of these down here. Basically, what I'm saying is, whether it's positive or negative, if it's less than 1, if it's fractional, like 2/3 or 3/5 or 1/8, it's going to start getting wider and wider depending on how tiny that fraction ends up. However, if that value is greater than 1, now it doesn't mean it can't be a fraction still. It could be like 12/5 or something, or it could be 15. That wouldn't fit on the graph very easily. But the bigger that number gets, the skinnier my graph is going to get. Because we always assume it's just 1 unless we see anything otherwise. But if there's one thing you are going to hear today, one thing, okay, what I'm about to say is going to be it. To find your vertex, the vertex is the centerpiece of our graph. If I can't figure out where the vertex is, I'm kind of screwed. So to find our vertex, here's what we're going to do. To find the x value of the vertex, we have a little formula. Negative b over 2a. Now you may have heard that in some other equation before, because it happens when you do the quadratic formula. Okay, this is a pretty decent sized chunk of it. And the other chunk of it we'll deal with a little bit later. But when I plug these values in, that's going to get me the x value for my vertex. And then how do I find the y? That takes a little more effort. We're going to substitute the x value into the function and solve. In other words, I'm going to substitute x in to whatever this y equals equation is, and whatever answer comes out is my y value. And then I'd have my vertex, or my centerpiece of my graph. And the vertex is so important because quadratic functions, parabolas, are symmetrical. So if I have the center point, I can kind of start to see where the other two parts come from. But if I don't have it, it makes things kind of look messy. So what I'm going to do on this first one is I'm going to show you how this would work if you don't have a graphing calculator at your disposal. Because it is possible to do these. And sometimes it's even possible to do them more quickly without it. So, when we deal with standard form, I need to look at this and figure out what my A, B, watch your signs, and C value is going to be within each one. Once I have that, I've got to get my vertex first. I've got to have that centerpiece for my graph before I do anything else. So to find that, again, it's going to be this negative b over 2a that we're plugging into. And again, watch your sign. So it's negative b, so the opposite of negative 4, over 2a. It will be. Yep, I just want you to see where it's coming from, but yes, it will be. The opposite of negative 4 is positive. 2 times 2 is 4. Okay, so I have the x value for my vertex. And I can even put that in down here if I want to. So now, to find y gets a little more interesting, and I'll even show you a shortcut here momentarily. But to find the y value of that now, normally I would take this equation, and then every place that I see an x, I just replace it with the x value. And again, some of you are like, well, I can just do that in my head. It's no big deal. And that's fine. Again, I want you to be able to see where this is all coming from. So 1 squared is 1. Again, the 2 is not in the parentheses. Square this value first. So 1 times 2 is 2. Minus 4 is negative 2. Plus 3 is 1. So my y value of my vertex is 1. So my graph is going to start at 1, 1. That's my center point. Now, a couple of things to keep in mind here. Number one, before I ever start graphing or doing anything else, which direction is my parabola going to be opening, up or down? Up. Because I have a positive value in front of my squared term. So here's how we normally would do it if we didn't have a graphing calculator. I'd make myself a little chart. In the middle of that chart goes my vertex, my centerpiece. Since this is going to be symmetrical, if I've done this right, I want 2 values that are less than my vertex x value, so 0 and negative 1, and I want 2 values that are greater. Now those values can change, of course, depending on what my vertex is. Here's the thing that's cool, though, because some of you are going, oh my gosh, so you're telling me I got to plug 4 numbers into this equation. This is going to take forever. I'm going to cut it in half for you. Here's how this works. The 2 values immediately, one above and one below the 1, are going to get the same y value out. So you only need to do this for one of them. So for instance, I love 0. 2 times 0 to the squares, okay, so we got 0, minus 0, plus 3. So that's going to come out as 3. That also tells me that my 2 value is going to be 3. As long as you're careful and pay attention to detail, you can get away with doing that. Now, if you get sloppy and you mess up the 0 value, now you mess both of them up. But that's one option that you have. I also have that option with both the values. What's that? Well, let's see. So here, if I plug in 3, so 3 squared would be 9, times 2 would be 18, so that's my first term. 4 times 3 is 12. So 18 minus 12 is 6, plus 3 is going to be 9. And that would be true for both of those values. So at this point, I would just go and say, okay, let me plot these other points. Again, they're going to be symmetrical. And again, these aren't absolute value equations. These aren't V's. They're kind of a U shape, so kind of get a curve in there as best as you can. The one thing with these graphs, and then I'm going to show you how to do it on the calculator too, that we haven't talked about yet is what's right below the vertex. What's this axis of symmetry thing? Easiest thing of this whole section. Whatever the x value is in your vertex, that is your axis of symmetry. You have to put the x equals in there. Because what the axis of symmetry is, kind of is the middle intersection of our graph. What its purpose serves is, if I were to graph this on a piece of graph paper, and then take it and fold it along that dotted line, I'd have equal parts on both sides to be symmetrical. So the axis of symmetry just allows me to be able to see that. Okay? So you're like, okay, this looks like there's a lot going on here. I mean, I'm finding x, I'm finding y, I'm figuring out all these numbers. This could take a while. Here's a backup option. Because there's still some things you're going to have to be able to do without the calculator. And I'll talk about that in a minute. So if I were to use the calculator for this, I could just plug in the equation just like I see it. Yeah. It should. You might be off slightly on one of your points if that happens. I'm going to go back and check it one more time. Yep, those are my x values. And then my y values are 93139. Oh, all right. Uh-oh. All right, let's check this out. It's actually set now when we get to it. So when I punch that in and see it, I'm like, yeah, that looks like mine. My vertex is just a little bit to the right of the y-axis. Here's the part that's cool, though. If you know your vertex, and you go ahead and you hit second graph to bring the table up, there's 1, 1. There's my vertex. Now, how do I know it's the vertex? Because now, look at the values just as you start to move away. 3 and 3. Hey, cool, there's 3 and 3. 9 and 9. If you see your table is symmetrical, if you get your vertex in the middle, then you know you found the vertex. Now, could I punch it in and just start scrolling up and down until I saw a screen that looked like this? Sure. But that takes some time, and I want to understand what's going on. So here's the part that I'm going to be kind of about with this. When you're doing one of these, I don't mind if, for instance, you get over to number 2 and you say, okay, Harty's doing all this stuff by hand. I don't really feel like doing this. Here's the one thing I want you to do. Before, move this out of the way, I always want you to find the x value of the vertex. That's one thing I'm going to require. So for instance here, okay, we have negative b over 2a. What's my b value in number 2? Okay, 1. So it's negative 1 over 2a. So negative 1/2 times 2 is negative 1. Negative divided by negative is positive. Okay. When we're doing when I'm looking for the vertex of my graph, once I find that x value, if I've got a calculator, and again, you can even get this online if you don't have one physically to use outside of class, what you can do is you can come back here and scooch this over a bit so we can actually see this. Now, when you go to type this in, it's just me. I like to use parentheses when I do this, just to make sure the calculator doesn't get confused. So negative 1/2 x squared plus x plus 4. And again, I could do this manually too, like we did in the first one. So once I get that, now Harty, this is going to be interesting. I know it should open down because I have a negative value in front of x squared. But how does just having this going to help me? Well, let me show you. If I hit second and graph again to get my table up, and I get 1 centered up in the middle of my chart, check it out. Not only will it tell me the y value, which saves me a little bit of time, my y value is 4.5. That allows me to have my whole vertex ready to go, which is cool. But then I can plot my 1, 4.5. But now also, when I'm sitting here and I'm a stickler about saying I want to see the rest of the chart, you don't have to sit here really and calculate a whole lot of anything. You can just say, cool, calculator's going to do the work for me. I like this. So I've got my 1, 4.5 in the middle, but I still want my two values above and below. So 0 and -1, 2 and 3. And then I just use the calculator gives me. So at 0 and 2 it's 4, and at -1 and 3 it's 2.5. And then I just plot those points. But again, I want to see, nope, it's still positive. Again, it should make a fairly nice, even though I don't even perfect the U shape. Okay, so like if I didn't have this at my disposal, here's what I would be up against. Instead of doing it this way, I'm still going to use that little trick that I talked about back before in saying I can still only have to do one of those for each of these. So let's just say I'm like, ooh, I see 0 as an option again. So here's what I'm up to. If I'm not sure, so let's say I'm going to plug in my 0 value. I'm going to take that equation, and every place that I see x squared, I'm going to plug in 0. Because 0 is nice, it wipes everything out. This is 0, this is 0. So it lets me see one of my points is going to be at 0, 4, and it also tells me what the value at 2 is going to end up being. I can do the same thing for 3 and -1. If I decide, okay, I want to do 3, because I don't like the idea of doing a negative here, I can go ahead, plug that in, and this you'd even be able to do on just a regular calculator. Or we can crank it out. Look at this, I say, okay, 3 squared is 9. Half of that would be 4.5, but it's negative. Let's see here, negative 1.5, that would be 2.5. This is what I would end up for -1 and for 3. And again, we're just trying to save you a little bit of time on that by only having to do 2 instead of 5. But that's an option you have. Again, whether I'm doing it manually, whether I even get it this way and then plug it into a regular calculator, or whether I use the table function. I'm going to end up with the same answers for all of them that way. Okay? Now there's one exception to you seeing a table symmetrically, and it's coming on the third example. Here's how this is going to work. Let me check one thing real before I go there. Are we doing okay so far? I want to make sure before I throw the weird thing in like that. Did not do the x equals symmetry yet. Thank you. I'm going to steal my x value from the vertex, so it's going to be 1 again. And again, x equals is always a vertical line. So we're going to get that going down the middle, and we see how bad my symmetry drawing was on this one. But yes, that's something we absolutely want to have in there each time. So now comes the doozy. Like it doesn't really look like a doozy. Even if you're using a calculator, I always got to see this vertex part come. So I've got -b, so -2, over 2a, or 2 times 3. This one's a little nastier, because it ends up being a fraction. Yuck. Here's the nasty thing about getting a fraction when you're doing these. You're like, well, what do I do now with my chart? I mean, -1/3. Here's the thing that really stinks. If you get really used to using the calculator all the time, I can stay away from the light. There we go. So I try to go plug this one in. And I'm going to find that I'm going to have a problem here. So I plug it in, I hit graph, it can open up, I know that much. So then I hit second graph to get the table. Oh crap, there's no fractions for x's. I don't see symmetry anywhere. What the heck am I going to do? Here's what we're going to do. Here's the one time you can kind of make an exception to the rule. We're still going to have to crank out the y value for my vertex. Okay? There's not going to be a real shortcut yet for that. However, what I will let you do is say, okay, so negative 1/3, the two whole numbers less and greater than that would be negative 1 and negative 2 as lesser values, and 0 and 1 would be my greater values. I don't mind if you then use the calculator, or if you're not using a calculator, just crank those out, because that's going to be a little bit easier to work with. And I can understand that. But how am I going to deal with the 1/3? Let me show you. What we're going to do with the 1/3 is we're going to have to just flat deal with it. So here's how we're going to do this. What's that? I was going to say, or you can slide over if you wanted to. Now again, even on a regular calculator, you could punch this in if you desperately wanted to. But we're going to go and deal with fractions here for a second. Negative 1/3 squared is 1/9. Because negative 1 squared is 1, 3 squared is 9. So 1/9 times 3 is 3/9, or 1/3. Some of you just getting to that part might be a little bit of a challenge. Okay? 2 times 1/3 is 2/3, but this would be negative, because I have a negative times a positive. And then the factor comes in. The 5 isn't in thirds. I need a common denominator in order to simplify this, which is going to be what? 3. Well, the nice thing is, the first two fractions are already in thirds. What do I multiply 1 by to get to 3? 3, so I do the same thing up here. So 5 times 3 is 15. Now that I have a common denominator, 1 minus 2 is negative 1, minus 15 is negative 16/3, otherwise known as negative 5 1/3, or negative 5.33. Okay? That one point, okay, that vertex has got to be accurate. That value has to get in there. We're not just going to approximate for that. Everything else we'll find a way around. So here, my vertex is at negative 1/3, negative 5 1/3. That's a little tricky to graph here. Yep, negative 1/3, so left 1/3, then down to 5 1/3. And then for the others, and you're like, well, wait a minute, if I just plot these other points that I got, whether it's from the chart or whether I actually crank these out, this doesn't look real symmetrical. It looks kind of lopsided. Well, we're going to do the best we can with this. I'll get my axis of symmetry in here to try and help me. X is negative 1/3. It's going to end up, yeah, it's going to end up still being a U shape. It might not be quite as symmetrical. What's that? Yeah, just 1 and 0. So that's the one oddball. You will not see many problems that end up that way. Most of them end up pretty nice as far as the numbers go. Okay? But that's the big thing. Use negative b over 2a to find your x. Plug that back in to find y, and then we just start using those 1 points away, trying to get there. Standard form is the longest form that you have to ever use. So you won't have standard form a whole lot. You'll get it some, but you'll get a mixture of things. So this is the longest one. It does get shorter. So the only other one we're going to take a look at today is vertex form. Then we're going to save the last form, our intercept form, for Tuesday. So let me shift this up a bit. Now we should see some things that are going to start to look a little more familiar. This should look familiar. Ooh, a vertex of HK. We just got done doing that quite a bit, actually. Absolute value equations and things like that. And the axis of symmetry still is going to be my x value, this h. So now with the vertex, I don't have to do that negative b over 2a anymore. Woo! My vertex is h, which is the opposite of what you see in here, just like before. So in this case, negative 1. And then whatever value is out there on the outside. Negative 1, 3. And there's my vertex. Is this going to be opening up or down? Down, because you have a negative a value. Now, just like before, you have choices. Negative 1, 3 goes in the middle. And I want two values that are less, two values that are more. Now, if you go to the calculator, and again, I'll show both. So I've got negative 1/2. Oops, I almost forgot my parentheses. X plus 1 squared plus 3. Okay? And unless you're going to use negative 0.5, you have to have the parentheses there, or you're going to get some weird looking stuff. So I go to graph. And I'm like, all right, my vertex there looks like it's about where my vertex is here. So let's look at the table. I want negative 1 in the middle. I press second graph to get this to come up. And it looks good because I see 2.5, 2.5, 1, 1, negative 1.5, negative 1.5. So if I've got this as an option, I'll just go ahead on these and plug them in that way. And again, if I don't do them all. Remember, it's like here I've got 0 and negative 2. They're going to get me the same answer. So I could just use the 0. That'll be the simplest number to use. And then same thing with negative 3 and positive 1. Well, we want negative 1, 3 is always going to be in the middle. I always want two numbers that are less. So one less than negative 1 to negative 2, and then another one less, and one greater. I want to see the symmetry, is what I'm trying to do. So if you just start in the middle, add 1, put that x value down, add 1, put that one down, and then the same the other way. It would be the same thing as just, for instance, I had one in my vertex of, let's say, 3, 4. I take 2x values less and 2 that are greater, and then I figure out the y. So my x values are going to change depending on what my vertex has to be, whatever my center value is going to be. Because once I get that, and then I start to plot those, I get my parabola, and where's my axis of symmetry on this one again? Negative 1. But that's how this one kind of simplifies up. Okay? Same idea. Yeah, let's look at one more. Figure this one out. So if we're looking at 5, what's my vertex going to be? 2. Put the number on the end. And again, this is an opposite because it's x minus h. So I'm looking at the opposite value. I'm looking for that vertex. So 2, -4. Now again, I know where my axis of symmetry is now. Right here on 2, where my vertex is. And again, when I go to make my chart, my vertex is in the middle. And with my x's, I subtract 1, and then I subtract another 1. And then I add 1, and I add another 1. And if I'm doing it by hand, I just pick either 1 or 3, plug that in. So let's just say we're doing it manually. So I'm going to plug in 3. 3 minus 2 is 1. 1 squared is still 1. Minus 4 is -3. That covers me on both of those. Then I do either 0 or 4. Let's say I do 4. 4 minus 2 is 2. 2 squared is 4. 4 minus 4 is 0. Okay, so even if you are doing it by hand, it's not something that's going to be, out of the realm of being able to do. Get my graphic and I'm done. So that's kind of where we're at. What's that? No, these are all positive numbers if you're talking about the x value. Because what I'm doing is I'm just signifying that when I go to plug these into my function, 0 and 4, whether I plug either of these in for x, is going to get the same answer out. Whether I plug 1 or 3 in for x, I'm going to get the same answer out. I'm trying to save you a little bit of time and not having to substitute all 4 of those in. Once you know what 1 is, oh, I see what you're saying.